Okay, so third hour. This is our data for each station. Data for stations 1 and 2, 3 and 4, right there. And we have 5 and 6. And we have 7 and 8. And then this is what we're discussing over here. We're looking through any data points that appear to be mistakes within the stations, and also looking at or trying to discuss what we may have thought happened. And then from that, we're looking at the station with the data that does make sense. What we know about mass, does that, what we saw happen there in terms of change of mass, does that seem to make sense with the change that we observed? All right, so we are going to start off with the wood splint. So there's our wood splint data. And let's get some share outs from different groups from their discussion. We're going to go ahead and share out. And the first one to share out is going to be Jaden. So, Jaden, what did you guys say about Station 1? First of all, is there any data that seems like it doesn't belong? You thought the plus 0.26, why? Why do you think that doesn't belong? Because the rest of them are negative, okay? Any other groups want to weigh in on this? Anybody disagree with that? Have a reason for that? Disagreeing with it? Okay, did you guys have any idea why maybe we got a positive there? Moses? Okay, so it's getting, okay, so less mass lost according to this. So it's kind of changing over time. So when we were doing that, were you guys using the same wood splints over and over? Were the wood splints getting smaller as we did it? It's things to think about. All right, so Jaden, what did your group say about Station 1, the wood splint? So apparently it's losing a little bit of mass. Did you guys think that that made sense, and why? You guys thought it did make sense? Okay. Okay, so you think this does make sense. Burning stuff away. So what does that mean? Burning stuff away. So what does that mean in terms of particles? We're losing particles, okay? So we say that we're losing particles at the wood splint station. Okay, might want to make those little notes on your data there. That could be helpful later on. All right, anybody else want to make a comment about Station Wood, the wood splint? Brennies? Okay, so Brynice just shared something about the data too. Um, so this is pretty major. So what she said is that when Kayla gave me this data that she accidentally said it gained when it actually lost. So that means that we have all loss of mass. All right. Okay, let's talk about Station 2, melting ice. And this is going to be Kari. So where's Kari? Kari, so what did your group say about the melting ice? First of all, is there any data that seemed like it was really out of place? Okay, so they're all increasing just a little bit. What did your group say? Did this make sense? Melting ice, the mass should increase a little bit? What do you guys think? What did you guys say about it? Okay, so if it's melting, it's taking up more space. All right, so that's one explanation. Anybody else now? Any groups want to comment? So if it's melting, the ice is taking up more space. Is that true, first of all? Kanye? You don't think that's true? Sorry about that. Okay, you were saying what now? The so is it taking up more space? You said no. Okay, so real quick, the amount of space it takes up, is that mass? That's volume. Okay, so if the volume changes, does that mean the mass is going to change? What is the mass again? Number of particles. So if we picture all those particles in the ice cubes while they're melting, does it make sense that we should get from the beginning to the end of leaving that station that all of a sudden there are some more? That doesn't make sense. Okay, what do you guys think about that? Anybody? Tayana says it doesn't make sense. Why, Tayana? You can't lose or gain mass. So these particles, when we have these particles in the ice cubes, and they're basically turning from solid to liquid, right? That's all that's happening. So if we are showing a gain in mass, this means more particles. So does that make sense, do you think? So Tayana says that does not make sense. Does anybody disagree? So what do you think should have happened? Okay, so these numbers, it's not that these numbers are necessarily inaccurate, but sometimes we have a little bit of built-in error, right? Is that what you were going to say, Adessa? What were you going to say? At every station, what? Gained particles? Okay. So every station seemed to have gained particles. Let's continue then. So we'll leave that for station 2 for now. All right, so steel wool pull apart. This one looks like this would be like a loss in particles, loss in particles, loss of particles, gained a ton of particles, loss in particles, gained some particles, gained some particles. So I mean, we see some areas where there are loss in mass, right? And that would be a loss in the amount of stuff, loss in the number of particles. All right. So the steel wool pull apart. Um, Moses, what did you guys say about this? First of all, is there any data you guys thought should not be included? Number 3, steel wool pull apart. Okay, so we've got some negatives. We've got some positives. Okay, so over here we got a positive. Here's another negative. This one. So you think something's up there maybe? Any idea what may have happened there? Well, that if it went up 32.95 grams, it gained a lot of particles. Kanye, you gonna say something? Jerry, you made a comment about this, I think, earlier. What were you saying? So, Jerry said, why do you think that, Jerry? Okay, so there's a drastic change in weight. Doesn't seem to fit the other data. Did anybody find the mass of the watch glass, Giovanni? Right. So here, yeah, it seems like this is kind of out of place, I would say. Nobody did the mass of the watch glass. Okay. I would bet, maybe you remember kind of, I would bet maybe the mass of the watch glass is somewhere around 33 grams. Okay. So that's a good clue. If we knew what the mass of the watch glass is, maybe we should leave that out. So according to the other data overall, now when we make measurements, I mean, it's expected that they're not all going to be exactly the same. Okay, so what do you think happened when we pull the particles apart in steel wool? Would it make sense that we could lose some? How could we lose some? Falls off, falls to the side of the watch glass, sticks to our fingers. Could it be possible that we could gain somehow? I mean, if we think about it, this is, and look at this, this is plus 0.02 grams and plus 0.05 grams. Not huge differences. Those are very close to being negative or zero, okay? So really what this is looking like overall, this data is kind of looking like, for the most part, the mass stayed the same. All right, isn't it? For the most part, in general, it's kind of stayed the same. All very little change. What about on the steel wool burn? Let's see who's going to tell me about steel wool burn. That's going to be Alex. So what about steel wool burn? Any data you want to kick out of there? You think there was some kind of mistake? So what do you guys think overall about this data? What is it kind of showing in terms of mass? That's just no change. It's just zero, so no change in mass. It gained mass? Is that what you guys said? Yeah, they do have pluses. Okay, so gained mass. Good question. Why would it gain if you're burning? Mass gained is what the trend looks like, right? How could that be? Gas particles. So gas particles, sure. Now, if it's mass gained, that means maybe we had some gas particles coming in. Something to think about there. All right. Station 5. Sugar dissolving in water. And here we have Ricky Rose. You guys have nothing for sugar dissolving? You didn't get a chance to copy the data? Didn't you guys talk about it? You guys didn't talk about it? Anybody in the group want to help them? Did you guys talk about it at all? No? Kyle Hawkins, do you guys talk about this, sugar dissolving? No? Right, what about this? You guys didn't talk about this data? Okay. Diana, do you guys get a chance to talk about this? What did you guys say? First of all, is there any data that you think is wrong? What's that? The ones that gained and lost? So what do you guys think should have happened? Why a little gain is okay? Okay. Yep. It's going to rise. What does that mean? Changing the size again? That's changing the volume, right? What do you guys think this? Do those seem a little out of place? Okay. Any idea what happened with that? Okay. All right. This is an area in the when we get to this part of the data, when we start observing this data, we're going to start seeing more mistakes. And the reason why is because with the when we start adding ingredients, some people are confused on that. Okay, so when we start adding ingredients together, what we got to do is we got to take in the mass before. So in this example, if we take the mass of the sugar and we add that to the mass of the water, those two added together actually equal our mass before. And that's what we have to compare to our mass after. All right, so that's why we get a lot of mistakes on these. Other than that, we had, so if we get rid of those, okay, this is even a little off, not too bad, but we didn't have data from group one. This is a small gain, this is no change, okay, and what were you saying again, Tayana? You said that you thought it shouldn't really change much, right? I was putting no change, even though we did see some change. I mean, if you really try to picture it at the particle level, and we're going to stop with this one, we'll continue talking about it tomorrow. But if you really think about it, break it all down to the particle level. You take all the particles you have in that sugar, and you're finding the mass, which is telling us the number of particles, really. And then you take the particles of water. If you add those two masses together, shouldn't that be the same as when you put the particles together? Shouldn't it? If we see any gains in mass, it means we have more particles at the end than what we started with. If we see any loss in mass, we have less particles at the end than what we started with. All right, so we'll continue this tomorrow.